Hi guys, and welcome to this video where I'm just going to introduce to you the three trigonometric graphs that you do need to have some knowledge of going into paper 2. So the first graph I'm going to show you is y equals sine x. The second one is y equals cos x. And the third one is y equals tan x. Now I know I've just thrown those at you very quickly. I'm just going to go through each one in a little bit more detail and explain how they're formed, what they mean, how we can use them. So going back to y equals sine x. Much like when we are drawing straight line graphs and we have things like y equals x, y equals 2x, y equals 5x plus 1, all you're doing is taking an x value, so something that's along the bottom, substituting it into your function, which in this case is y equals sine x, and then plotting whatever the y value is. So this graph is actually plotted by taking x is 0 and putting it into this function and plotting the point that comes out. Then x is 1, putting it into the function, x is 2, and so on. And you get so many points that it forms this smooth curve. Okay, so if I go to my printout of y equals cos x, you'll notice this looks much bigger. Now the only reason for that is because this was probably the best quality image that I could find online when I printed it. So I could actually have a very similar graph for y equals sine x. You can see that this starts at 0 and ends at 360 degrees. Whereas here, it starts all the way at minus 360 and ends at 720. So y equals sine x, the one that I've got printed up here, is just a snapshot. Okay, it's just this snapshot between 0 and 360 degrees. So something that you might notice, and it's a lot easier to see when we look at the larger graph, y equals cos x, is that this shape, it repeats forever and ever. Okay, I could extend it even further and this pattern would carry on, this wave. So if you look, I'm just going to kind of isolate part of it. That shape is repeated here and here. So they are just built up one after the other. That's how you could think about it. So if we look here, we can see the graph starts at 0, does this wave pattern, it reaches 0 again, and actually if I carried that on, I would see it moving up here and that pattern repeating itself. It goes on forever. So that is something that's really important to know about trigonometric graphs. They do repeat forever. So you'll notice that sine x and cos x, they look really similar. So if I just get my tan graph back, this looks completely different. So I think this is probably the least likely thing you will be asked about, but it could come up. You just need to have some awareness of it. So much like y equals sine x and y equals cos x, this was formed in exactly the same way. Someone just computed what tan of 0 is, tan of 1, tan of 2, tan of 3, tan of 4, tan of 5, and they plotted this graph. Now tan behaves a little differently to sine and cos. When it reaches 90 or 270 or 450, so that's every 180 degrees, it behaves quite oddly. It actually becomes infinitely large. It will never actually have a defined value at 90. Tan 90 isn't defined, it's just so big. Tan 270 isn't defined. Okay, so it's still exactly the same thing, it just looks a little different. So it's just really important to at least recognise the shape, recognise that this is different to cos x and sine x. So if I just go back to the two that I was talking about before, we can see that every single x value has got a unique y value. Sine of 60 is shown here, sine of 90 is shown here. Okay, so they've got unique values. However, if I asked you what sine of what x value I would need to get an answer of 0.5 or 1/2, you could see that sine 30 gives me that, as does sine 150, and this would carry on. There'd be 390. That would also be that would also give me a value of 0.5. So actually there are lots and lots of different values that lots of different y values, got that wrong way around, lots of different x values that produce certain y's. Lots of different values of x can give the same answer. Okay, something that you also should know is that there is a symmetry in these graphs. Okay, so each section of this wave, of this curve, is symmetrical. So you will notice if I find my start point and my end point of this little section, so both at 0, if I go 30 across and up, I get 0.5. If I go 30 across and up, I get 0.5. If I go 60 across and up, I get somewhere around 0.8. 60 across and up, again I get somewhere around 0.8. So there is a nice symmetry there. You can see using a ruler, a straight line, that they would have exactly the same value. So the sine and cos graphs, they have got that symmetry, which is a useful fact that you will potentially be using later on. Something also that you may have noticed, they've got the same shape. And actually, if I just try to get them side by side, might be a little bit difficult. You can see the sine graph starts at 0, and then sine 90 is 1. So it is going up, 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 reaches 1, and then starts going down. Now, there is actually a relationship between these two. If you imagine shifting this cosine graph 90 to the right, so this point went to here, this point went to here, this point went to here, you'd actually have a sine graph. So they are very closely related. So I think they are pretty much the basics of trig graphs, kind of the properties, the basic visual elements. So I will actually be moving on to some examples of drawing them and how we would have to go about doing that. So let me just get my blank piece of paper. So I say blank piece of paper, I do mean I've got a blank grid. Okay, so this is actually taken from a pack of past exam questions, and we are being asked to draw the graph of y equals sine x for x is greater than or equal to 0 and is less than or equal to 360 degrees. Okay, so that's a really important thing that we do need to be aware of. They've limited the values of x they want us to focus on. Okay, speaking of focus, just need to sort that out. Because that sine graph you've just seen would go on forever, as would the cosine graph. So it only wants us to focus on one little section of it. And the most common section is between 0 and 360 degrees. So what I would do in this situation is just plot a table. So x and y, which we know is just sine of x. And what you would do in this situation if you are ever given a question where you have to draw a sine graph. Bear in mind this is a calculator exam. This obviously only refers to the 2022 specification. If you're looking at this in the future, this may be coming up non-calculator. But for the purposes of this video, I'm just going to be using a calculator because I know in your exams you are going to have access to one. So you're not expected to remember exactly what that looks like. So what I would recommend you doing is just plotting some values using your calculator. So what you should do is just go up in jumps of 45. I think that is a good enough level of accuracy. You can see that this jumps up in 90s So we are going to plot a point at 45, 90, 135, 180, 225 and so on, just to make it a little bit more accurate. So 0, 45, 90, 135, 180, 225, I'm going to go down here, 270, 315, 360. So all I'm going to do is get my calculator and type in sine of 0. Sine 0 is 0. Sine 45 is root 2 over 2, so about 0.7-ish. Sine 90 is 1. Sine 135 is again 0.7-ish. You can see that symmetry emerging. And sine 180 is 0. Now sine 225 is minus root 2 over 2, so minus 0.7, whatever we've got there. Sine 270 is minus 1. Sine 315 is minus 0.707, and sine 360 is 0. So we've got a series of points that we can plot. Remember, it is only a rough sketch. Also do remember, sine of anything can never exceed 1 or minus 1. It's going to be between those two. So what I'm going to do is mark on my two maximum and minimum points. Remember, this is only a rough sketch. It's not going to be perfect. I'm well aware of that. So I know that when x is 0, y, or sine of 0, is 0. Okay, at sine 45, so 45 is about here, I know my value is 0.7. So I'm going to just roughly plot 0.7 there. When x is 90, sine 90 is 1. When x is 135, so about here, it's going to have the same value as it did over here, 0.7-ish. When x is 180, it's going to be 0. When x is 225, it's going to be minus 0.7. When x is 270, it will be minus 1. When x is 315, it's minus 0.70 again. When x is 360, sine 360 is 0. So you can already see that pattern emerging. So you could actually have gone up in smaller steps. Some people like to go up in steps of 30 because you would actually see some nicer numbers emerging, but the issue with that is you'd have to do that 12 times. I've just sped it up a little bit. I've only done it 9. So all I need to do now is join those up with a smooth curve. Now I would recommend doing this with a pencil, but then just for the purposes of the exam, bearing in mind that it's being scanned in and being marked on a computer screen, maybe go over it in pen just to make it really stand out. So remember, it's a smooth curve, don't do a dot to dot. And it is only a sketch, it's not going to be perfect. You'd need a computer to draw it perfectly, but it would look something like that. Okay, so if I compare it to the printout I had, the really accurate one, obviously it's been squished down a little bit, but you can see there are similarities. This is much more stretched out, but again you can see general shape is still the same. Okay, I'm quickly just going to do Cos X using a similar idea. So this is how I would recommend approaching it in an exam. You may remember the shape. Obviously I've been doing this for a long time. I do remember what they look like, but this is a really good way in an exam of making sure you hit all of those marks. So just draw out your table again. So we've got X and Cos X. and we're just going to jump up in 45s again. So 0, 45, 90, 135, 180, 225, 270, 315 and 360, just about. So again, just use my calculator. I'm going to get cos of 0, which is 1. Cos of 45 is again that 0.7 number we saw before. Cos of 90 is 0. Cos of 135 is that minus 0.7 number. Cos of 180 is minus 1. Cos of 225 is minus 0.7. Again, that's symmetry emerging. Cos of 270 is 0. You can probably guess where this is going. Cos of 315 is 0.7. And cos of 360 is going to be 1. Okay, just show you that on the calculator. Now you could have chosen other values. So cos 30 and cos 60 give you some useful values as well. So cos 30, cos 60, you could just add those in just to make it a little bit more complete, just to make sure it actually looks okay. But just for the sake of this, I'm not going to worry about that. So I'm just going to plot this again. So when x is 0, cos of x is 1. So remember, a cos graph starts high up. When x is 45, cos 45 is 0.7ish. When x is 90, cos 90 is 0. Cos 135 is minus 0.7. Cos 180 is minus 1. Cos 225 is minus 0.7-ish. Cos 270 is 0. Cos 315 is 0.7. Cos 360 is 1. And again, just join that with a smooth curve and you will recognise the shape from before. Oh, that's why you need to have a pencil so you can rub it out when you inevitably make a mistake like that. So that is the shape. And again, if I compare it to what I showed you before, there are similarities. If we just focus on that point there, it looks pretty similar to me. Okay, so hopefully that has been really helpful. One thing that I will just show you before I go, I'm going to go back to my properly printed sine graph, and I'm just going to ask this question. Find the value of x where sine x equals minus 1/2 in the interval x is greater than 0 but less than 360 degrees. So where would what value of x would give me an answer of minus 1/2? So what I would do is find this value on the side. So minus 1/2 is here, and I'm just going to draw in a line. Nice straight line going from minus 1/2 all the way across. Okay. So I can see that line intersects my sine graph here and here. So that is saying, using my graph, that when x is 210 and also when x is 330, sine of x will be minus 1/2. Let's just double check that. Sine 210 is minus 1/2. Sine 330 is also minus 1/2. Okay, now the good thing about that is you can see more than one value. If you just use your calculator, if you just use the inverse sine function, it can only give you one value, and it might be a little bit weird. That goes well beyond the scope of GCSE, so I'm just going to type that in, and yeah, it gives you minus 30. Okay, if you go on to do maths at a higher level, you might see why that is the case, but you can see the instant issue. You can't use your calculator to solve this problem. You would need to have a graph. So I hope that has been helpful, guys. In my next video, I'll be going through some more exam style questions. See you later. Goodbye.